You ever get that gut feeling when you're about to make a risky choice? But what if you could actually put a number on that feeling? Well, that's exactly what we're going to do today. We're going to break down the math of probability and this incredibly powerful tool called expected value so you can see the real logic behind luck. I mean, think about it. Whether it's a simple coin flip, deciding to buy a lottery ticket, or even just making a friendly bet on a game, we are constantly trying to figure out what's going to happen next. But what if we could do a lot better than just, guessing? And look, the math we're digging into today isn't just for some chapter in a textbook. This stuff is the hidden engine that powers everything, from your insurance rates to Wall Street trading algorithms, and even the artificial intelligence running on your phone. So understanding this isn't just about passing a test, it's about understanding how the modern world actually ticks. Okay, so to get there, we've got to start with the fundamentals. And it all boils down to one simple, really elegant formula that basically governs the likelihood of, well, just about anything. This little fraction right here is the bedrock of everything. To find the probability of pretty much any event, you just take the number of ways you can get the result you want, and you divide it by the total number of things that could possibly happen. That's it. It's a simple ratio that lets you quantify your chances. Now, there are a few ground rules we gotta know. First, probability is always a number between 0, which means it's impossible, and 1, which means it's a total certainty. You're never going to have a 120% chance of something. Second, the complement rule is super handy. The chance of something not happening is just 1 minus the chance that it does. And finally, there's the addition rule, which helps us figure out the odds of this or that happening. We're not going to dive too deep into that one today, but it's good to have it on your radar. All right, theory is great and all, but let's make this real. We're going to take that core formula and apply it to a classic problem that you've probably run into before. So picture this. You've got a bag with a mix of red, blue, and green marbles. If you reach your hand in without looking, what are the actual odds that you'll pull out a red one? Let's use our formula. Step 1, we count our favorable outcomes. In this case, the outcome we want is a red marble, and there are 3 of those. Easy. Step 2, count the total outcomes. So we just add them all up, 3 plus 4 plus 5, which gives us 12 marbles in the bag altogether. And for step 3, you just divide the favorable by the total. And boom, there it is. 3 divided by 12 gives us 0.25, which of course means there's a 25% chance of drawing a red marble. Simple, right? Clean. Powerful. Okay, but this is where it gets really interesting. We can take this idea of probability and use it to actually make decisions. This is where a concept called expected value comes in, and it helps us answer a really important question. In the long run, is this a good bet? Think of expected value as a way to predict the average result if you could do something over and over and over again. All you do is take each possible outcome, multiply it by its probability of happening, and then just add all those little pieces together. Let's see it in action. Imagine you're at a carnival. There's a game, and it costs $5 to play. Now, you don't have a great chance of winning, only 20%. But if you do win, you get a cool $20 prize. So, should you play? Your gut might be telling you yes or no, but the math gives us a much clearer answer. First things first, we have to figure out the net outcomes. What do you actually walk away with? If you win, you get that $20 prize. But remember, you paid $5 to play, so your actual gain is only $15. And if you lose, well, you get $0, but you're still out the $5 you paid. So that's a net loss of $5. This step is absolutely crucial. Now we just plug those numbers into our expected value formula. We take the win value, that $15 gain, and multiply it by its 20% probability, which gives us $3. Then we take the loss value, that negative $5, and multiply it by its probability. And if there's a 20% chance to win, there must be an 80% chance to lose, which gives us negative 4. Finally, we just sum those two values up. The expected value is negative $1. Now, this is so cool because it tells us the true value of playing this game. It doesn't mean you'll lose exactly $1 every time. It means that if you were to play this game 100 times, you should expect to be down about $100. From a purely mathematical standpoint, it's a losing bet. Now, as you start playing around with these ideas, I want to give you a heads up on a few common traps that can really trip you up. Let's go over them so you can avoid these simple mistakes. Okay. This one is the golden rule. It is non-negotiable if you ever do a calculation and you end up with a probability of 1.2 or 120%, stop right there. you know immediately you've made a mistake. Just go back and check your work. Because probability is always, always capped at 1. Here's a little language hack for you. Pay very close attention to 2 little words, and or. If a problem asks you for the probability of this and that happening, it's almost always a signal that you need to multiply the probabilities. If it asks for this or that, you're probably going to be adding. It seems like a small detail, but it makes all the difference. And here it is, probably the most common mistake people make with expected value. It is so easy to forget about the initial cost of playing. Remember our game? We didn't use the $20 prize in our calculation. We used the $15 net gain. You have to always account for what it cost you to get in the game.
So you see, this stuff isn't just for marbles and carnival games. Let's talk about a massive, multi-trillion-dollar industry that is built entirely from the ground up on the idea of expected value.
That's right, insurance. The entire business model is basically one giant expected value problem. They calculate the average amount of money they expect to pay out for each customer, and then they set their price, the premium, just a little bit higher than that so they can make a profit. Let's run a quick, really simplified version. Let's say an insurance company covers an event that, if it happens, leads to a huge payout of $100,000. But they've done their homework. They've crunched all the data, and they know the actual probability of that event happening is incredibly small. We're talking just 1/10 of 1%. So what's their expected cost per customer? Well, we just multiply that massive $100,000 payout by its tiny 0.1% probability. And the result? Just $100. That single number is everything to them. It tells the company that to stay in business, they have to charge their customers more than $100 for that policy. And just like that, an insurance premium is born. And that's the real power here. This math lets us take something as fuzzy and vague as risk and turn it into a cold, hard number. It's the tool that helps us decide if a gamble is smart or foolish, whether we're standing at a carnival booth or looking at the stock market. So the next time you face a choice with an uncertain outcome, don't just go with your gut. Ask yourself, what's the expected value?